Hi guys, I'm gonna teach you how to find the derivatives today of trigonometric functions, the exponential functions, as well as the logarithm functions. So we'll start with trigonometric functions. And to do the derivatives of trigonometric functions, you first have to know a little bit of trigonometry. So let's remember what is called compound angle formulae. So we have sine of two angles that are unknown. They are variables. And we want to express this in terms of the individual sine and cos functions of alpha and beta. So how do we do that? And there's an easy way to remember this. And I always say, depending on what language you use, you'll say C sine alpha cos beta plus cos alpha sine beta. And to remember this, you can say what? The compound angle. We say compound because we're adding two things here, two angles. Remember, one simple, two compound, and three or more is complex. So this is a compound angle formula. A lot of them compound angle formulae. So to remember this, we would say C co C or psi co psi. Okay, which are these first two letters of the trigonometric ratios involved. And then the order of the angles remains the same there. Then what is to also notice here is that if there's a plus for sine here, when you're working with the sine, there's a plus also between the terms on the right hand side. The same thing is true if you have a minus between the angles. You will still have a minus there between the two terms. So with the sine compound angle formula, you have what? If you have sine alpha minus beta, the terms on the right hand side will also have minus. If you have sine alpha plus beta, the terms on the right hand side will also have a plus. And to remember it, C co C or psi co psi. Okay. And then for the cos, we have what? Cos alpha plus beta will be equal to cos alpha sine beta minus cos alpha cos beta. My bad, sorry. Cos alpha cos beta minus sine alpha sine beta. And to remember this one, we'll say co psi psi or co c c. Okay. Now also what is to note here is that if it is plus, if the angles are added here, the terms are subtracted. If you have minus, then the opposite is true as well. So when they are summarized like this, you must note that the signs on top go together. So here the plus here goes with the plus there because they're both on top, and the minus here goes with the minus there. But the bottom line is that on the sign that is between the angles is the same as the sign between the terms on the right hand side. For cos, it is the opposite. The sign that is between the angle is opposite to the sign between the terms on the right hand side. And then the last one, which is tan of alpha plus beta. This one involves only the tan ratios. And it is what? Tan of alpha plus tan of beta, right? All over 1 minus tan of alpha times tan of beta. And to remember it is that it's tan plus tan over 1 minus tan. Right, and then if there is a minus between the two, then because we know tan is actually sine over cos, we know that the top one, the signs will be aligned to the signs on between the angles, because we know for sine the signs don't change. So even for the tan, we remember that because on top we have sine, at the bottom we have cos. This comes from tan theta equals sine theta over cos theta, right, from grade 11. Right. So the sine is related to that compound angle for sine. So the sine that you have between the angles is the same sine that you'll have on top for the tan. And then at the bottom, you'll have the opposite because you have cos. And we know for cos, the sine between the angles is opposite to the angle between the terms. All right, so those are the compound angles for sine, cos, and tan. Now, we won't go into detail as to how you apply this, but there are definitely videos that we have where we apply this compound angle formula. And they happen a lot also when you do trigonometric identities. Okay, but also when you are doing derivatives for the trigonometric functions in calculus. Okay. Now that we know our compound angle formulae, which you can have on the side and practice a lot so you can know them off by heart, we are ready to do the derivatives of sine, cos, and tan from first principles. Okay.